So z is z cubed plus z squared plus pz plus q. P and q are real constants. We're told that f of z equals 0 has three roots, z1, z2, z3. And when plotted on our Argand diagram, the points representing them form the vertices of a triangle of area 35. So this is nice. This makes this question a little bit different. And given that z1 equals 3, find the values of p and q. The first thing I can do is sub in that 3. F of 3 is going to equal 27, that's 3 cubed, plus 9, plus 3p plus q, and it's going to equal 0, which means 3p plus q is going to equal minus 36. Right, so we've got an equation. What to use next? We might think to try the area of 35, because it is like the other piece of information we have, or another piece of information that we have. We'll see there is another, in fact. So if I put my Z1 here, well, the problem is that there's actually, lots of different possible. So what I would say is actually the other two roots have to be complex numbers, because if they were real, then they would be along here. You wouldn't create a triangle. In theory, I guess they could be purely imaginary, but they're going to be complex in general. So this, for example, might create an area of 35, but maybe I could do this one instead. So I don't really have enough, well, I just don't have enough information to draw a diagram and figure it out. But the other piece of information we do have is actually, okay, we don't know what P or Q are, but we do have the A and the B coefficients of the cubic. And this is actually crucial because if you sum the roots of the polynomial, the sum of alpha, then it's actually equal to minus b over a, which in our case is minus 1. And that is how we're going to figure this out. So therefore, z1 plus z2 plus z3 is going to equal minus 1. And we know what z1 is. Now we don't know what z2 or z3 are, but we do know that they've got to be complex conjugates because they're both roots of this cubic. So I can say that I've got x plus iy plus x minus iy equals minus 1. The complex parts cancel. So 2x equals minus 4, x equals minus 2. And now we can create that triangle. Because if x is minus 2 here, then what we have is a height for my triangle of 5. So then, so I'm calling it the height because like you normally draw your triangle like that, and then that's the perpendicular height. So then the base, this vertical length, let me just call it, well, that's actually going to be 2y, in fact. So I can say that half times 2y times 5 must equal 35. These cancel. Y is going to equal 7. And I've got the roots then. So I can say z1 is equal to 3. z2, without loss of generality, I can say it's minus 2 plus 7i. Of course, what I'm saying is I could swap them around if I wanted to. And then minus 2 minus 7i. Okay, I've got to say, this I think is the hardest question in the paper. So just want to backtrack. We've substituted 3 in. I mean, that seemed quite logical to get an equation, but actually not then used that equation yet. Drew a little triangle, realized, oh, that's not going to help. Realized actually we need to use the sum of the roots, and then actually we could work out all of the roots. That was good. From that, oh yeah, sorry, from x, used the triangle to get the y, so then we had all the roots. Now we need to work out p and q, so I need to somehow get another equation for p or q. And let's return, I mean, there's actually lots of different ways to do it, and I would recommend having a look at the mark scheme. But what I decided to go with is multiplying the 3 roots, because alpha, beta, gamma. So when you sum the pairs, it would be c over a, and then when you just have the triples together, it's going to be back to minus d over a, which is going to be minus q. So that means that 3 times minus 2 plus 7i times minus 2 minus 7i is then going to equal minus q. And let me multiply this out. It's going to be a difference of two squares. I'm going to get 4 minus 49i squared, so plus 49, and that's going to equal minus q, which gives us q equals, because this becomes 53 times by 3, 159, then it's negative, so it's minus 159. Okay, going to put a little box around that one. And now, I mean, there's other ways you could do it, but it just makes sense now to use the 3p plus q is minus 36. So 3p minus 159 equals minus 36. And if you solve this, you end up with p equals 41. Okay, well done.